How's it go, team? So we're gonna be doing flipping the matrix. It's one of the medium algorithms. Quite difficult, actually. Okay, so the core to the solution, right, is to understand a couple of things. So thing number one, I actually wrote them out in here. Now, matrix can only be even. So if you read through it, you will see that it's 2n by 2n. So n can be anything. N can be anything from 1 to 125, but it's always going to be even because we're always multiplying by 2. So think about it this way: if n is 1, matrix is going to be 2 by 2. If n is 2, matrix is going to be 4 by 4, right? And vice versa. If n is 3, it's going to be 6 by 6. So it's always even number, right? Now q in here is completely irrelevant. You don't need to think about it at all, right? And then I think that's the most important thing. Yeah, I can reverse any row or column. The goal is to maximize this quadrant in here. You see this quadrant in here. Now we'll come to that in a sec. So I think this is the most important thing. This is kind of okay. Yeah, so n will be equal to length of the matrix divided by 2, but that's irrelevant as well. The most important thing is to understand that matrix is always going to be even, and you can divide it by 2, always. Okay? And then, now, so that's first thing. Second thing, you have to understand, this is the trick, this is actually the trick to solve it, all right? Whoops, let's just put, yeah, actually, let's do that, all right? Now, now, do not try to think in terms of what can you flip and what can you not. Well, you have to think in terms of flipping. Okay, so the most important thing is to see the 4 pairs that you can flip around. All right, so you can flip around this and this, this and this, this and this. Okay, because you can rotate the row and you can rotate the columns. Does that make sense? So you can flip around 108 with 119. So that's going to be one pair. Then you can flip 112 with 19. Right? That's going to be another one. And then you can flip 112 with 62. That's another one. And then 62 with 108. Does that make sense? So think about it as a mirror. Every number on this matrix is going to have a mirror. Right? So 108 can be flipped with 62, vice versa. We can flip it this way. We can flip it this way. We can flip it this way. And that's the most important thing. There's always going to be 4. It doesn't matter how big the matrix is. The mirrors are always going to consist of 4 numbers. That's probably the most important part of this exercise. Okay. So now all you have to do is to find the mirrors, right? So 42, 83 is another mirror, right? Now 42, 92 is another mirror, right? Because you can flip them. 80, so you can flip 98 with 14. That's another mirror. And then 114 with 83. So this is the 4 numbers that are mirrors, right? Next thing we are going with here. Now naturally 5615 is going to work. Let's put green. 56 can be flipped with 49. I'm gonna put it as green. 49 can be flipped with 43. That's another one. And then 43 can be flipped with 15. All right. Oh, okay, so now we're left with this. This is naturally the only way you can flip them around. So that just by default becomes mirror of itself, right? Okay, so the most important thing to understand, number one, is that mirror numbers always 4, no matter how big is the matrix, okay? The second thing is that this quadrant here can be consisted of any mirror, of any one mirror, right? So in this quadrant, there can be one number from yellow, one number from red, one number from green, and one number from gray. So, all right, so in this quadrant, there's always going to be one number from every mirror pair. Well, not mirror, like think of these mirrors as an array of numbers, right? So from that, there's going to be 4 numbers, 1, 2, 3, 4, okay? So from that mirror in this quadrant, there's always going to be one number, always, right? Which means that from every single mirror, all we have to do is find the biggest number in that mirror, right? So once we find, so what's the biggest number out of yellow? What's the biggest number out of red? What's the biggest number under green? What's the biggest number under gray? Because one of those numbers will always be in this quadrant. And then that's it. You solved it. It says it's that's it, right? So next thing you have to understand, right, in here is that um, every, well, let's call it mirror, okay? So mm, of 4 numbers, one number will always be in the upper left quadrant. All right. So all you have to do is find, all we have to do is find the biggest number from the mirror of 4 numbers. Now, okay, and the tool for that we're going to be using is called mathmax. Now, look up how mathmax works, but basically what it does is if you put in numbers into mathmax, so for example, 112, 62, 119, 108, it will pick out the biggest number from that from those 4 numbers, right? So you have a tool that will literally pick out the biggest number from these numbers. So it's going to be 119, right? So all you have to do is figure out how do I feed these numbers into the tool, and I'll show you how to do that. Okay, so that's going to be your key to success, is going to be mathmax, right? All right, and the final thing you have to, so this is targeting, right? So for you to be able to target these elements in here, you're gonna have to split the length into 2, but I'll show you how to do it. I'll show you how to do it, right? The most important at the moment, just focus on this, right? The most important thing is to find the 4 mirror numbers and pick out the biggest out of those 4, and it will naturally end up in here. So you don't even have to worry about flipping anything, right? Just find the biggest number out of the pair. I also did it on like a smaller or bigger version of an array, and it also works. It 100% also works, right? Because if you look at the color pairs, mirrors, right? Every color is always represented one time in this quadrant, right? So again, there is always 4. So think about it, there's 4 yellow, there is 4 green, there is 4 brown, right? But in this quadrant, there is always one representation of every color. So again, all you have to do is target these 4, I suppose, 4 mirrors and get the biggest number out of it. And that's it. And then it's going to work. All right. And that's it. That's the solution. Okay, so now let's start actually doing it. So I am going to move this in here, right? I have the big matrix, but we're gonna do it with the small matrix first. Now, my apologies for this. It's just I was experimenting on, what works, what doesn't work. So this is gonna be input one. We're gonna feed it into the matrix. Okay, so what's the first step? Bum, 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 bum. So the first step is we need to, well, let's console log the matrix real quick. Okay, so the first thing we need to do is we need to cut the length into two, right? So let, I don't know, length split is equal to matrix dot length divided by two, right? Now, now it probably won't make sense to you why we're doing it at the moment, but just um, go with it. I'll show you. I'll show you later why we're doing it. Okay. So the second thing we're gonna need is we're going to need two for loops, right? Because with for loops, we are gonna be going. Let me just move this here. So when you have two for loops, you can go like this, and you can go like this, right? Because when you think about the first for loop, is gonna go look into every um, array, right? Because every array is effectively a row. Okay, so it's gonna go like this, and then we need second for loop to go through the columns like this, right? So on the first rotation, it's gonna be um, for loop I0, so there's gonna be this array, okay? And then the second for loop is gonna look through the columns, so it's gonna be like this, like this, like this, and like this, right? Now, the reason why we're splitting into two is because we want to be able to access this um, this right parts. This is where it gets gonna get a little bit confusing. I'm trying to explain it to you. The reason why we're splitting into two is because if you go full length, you will not be able to access this, right? Unless you do it, unless you start hard coding values. And when you start hard coding values, you will not be able to scale the matrix, right? So you have to split, and you have to use um, well, there's two reasons why I do it, right? First of all, you need to stop matrix from going four times. You just need to do it half the matrix. Well, I'll show you. It will make sense, I think, once we. I don't know. Some things in programming is just very hard to explain. You just have to see it. All right. So we're creating two for loops. So for variable I is equal to 0, I smaller than. So we need this thing, length split, right? So let me just console log it so you'll be able to see that it's going to be 2, right? And then I plus plus, there you go, you see, so now it's 2. So the matrix is 4, and we're only concerned with half of it. So that's going to be 2. All right, so in this case, I is going to be 0 and 1. Now, I'm trying not to confuse you, geez, okay. Okay, so 0 is going to go like this, and then it's going to go like this. Okay, well, you're going to have to, it's probably going to take you like 3 hours to figure this out alone. You're going to have to play around. I strongly encourage you not to use it in your head. Draw it, and figure out how the for loops move through every single cell. So we are basically using for loops to target every one of those elements. Okay. So now we need to nest another for loop. So this will be end of for loop I. So we're nesting a second one for, we can do let j equals 0, j smaller, again length split. And then j plus plus. Now, if we console of j, it's going to be 0, 1, 0, 1. Okay, and the second thing we need to do is we need to find the full length. Let full length equals okay, full length is going to be probably, all right, so full length is going to be this index in here, right? Because when you think about it, full length is going to be 3. Let me just, you know what I'm going to do? I'm going to get rid of, so it doesn't confuse you. Yeah, so now we're going to console log length, and it's going, whoopsie. Yeah, so it's going to be 3. So think about it as 4 arrays, right? So array 1, array 2, array 3, array 4. We're going to have I, which is going to be index, right? And it's going to be 0, 1, 2, whoops, 2, and 3. So in order for us to access this, we need to know the full length of the array. And remember, array is always 4 by 4. So whatever the length of this is, whatever the length of the array is going to be the length of the column. Okay, so we need this length to know how to access this, and this. That's why we have this length. Now again, you cannot hard punch a 3 into it because array could be bigger, right? It could be 6 by 6. That's why you need to have the length. Okay, dokes. Okay, so now we're gonna create a let array mirror numbers. So now this is where we're gonna start pushing. We're gonna start pushing the color numbers into here. Okay. Now, okay, before we do that, we need to first target the elements, right? It's gonna get very, very, very confusing. I'll try not to confuse you. Okay. So on first rotation, we need to be able to target 112, 62, 119, and 108. Okay. The way we do it, so the first one, so first you also have to remember that there is J running in here. So I is going to be, let's just put J in here. And J is going to be, so, how to explain it to you? Okay, so this is going to be J0. This is going to be J1 out of for loop, right? This is going to be length minus J, because J is 0, length is 3, so this number is going to get targeted. And this is going to be length minus J on second rotation. Because on second rotation, J is going to be 1, right? So length minus 1 is going to be 2, which will land you on this number in here. Okay, but we're not really too concerned with that at the moment. All right, so oh my god, that's gonna be so difficult. I'm trying just not to confuse you, you know. And in here we're gonna have the same shite, only it's going to be length minus I, and then length minus I. So here's going to be the second one. So length minus I is 3 minus 0, which will give us, my apologies. So length is 4. 4 minus 0 is 3. So we're going to land in here on this array. And then when I is 1, right, when I is 1, length 4 minus 1, shit, wait. Yeah, because length is 3. We put length as 3, right? Yeah, we did. Yeah. So 3 minus 0 is going to land us in here. 3 minus 1, length 2, is going to land us in here. Right, so now we pretty much have access to every possible quadrat in here, right? That's why you cannot use for loop, because if you use for loop, you will not be able to do that. That's why you have to split the array into 2 and then use length minus j and length minus 2 to be able to target in the same loop, right? Now this is probably one of the hardest parts, right, to figure this out. Okay. All right, so now let's try to target. Actually, what I'm gonna do, I'm gonna copy this. I'm gonna put this in here so we'll be able to. So this is gonna be A's. All right. Let's put this as B. Man, I'll make it bigger. So this is gonna be B. This is gonna be C. And let's gonna make this D. Okay, so let's first try to target A's, right? So what do we need? We need I. I is gonna be going. Oh my god. So let's just do. Actually, we need to probably do A1. Okay, so let's target A1. A1. But they're going to change. God damn it. Because they're not going to be A1. Well, just for demonstration purposes. Right, let's do A1. Let's console log. Console log. Which is going to be matrix I, J. And then we're going to console log it, right? No. So let A1. Oh, that's because we're console logging console log. Yeah, we're trolling. Yeah, we're trolling. I even confused myself. Okay, so on the first iteration, we have our this number here. We have A1, right? Because I is equal to 0 and J is equal to 0. So this will give us this. Next, we need to get this number here, okay, on the first rotation, which means that J is going to be 0. J is going to be 0, right? And I is going to be length minus 1. All right, so we try to get 62 right now. So the way to do that is, let's do let A2 is equal to matrix. So we are only changing I in here. So J stays the same, J 0. And I is going to be full length minus I. Because at the moment I is 0 on this rotation, right? So we have 62. We're gonna have 62 in this. Whoops. Yeah, so you see 62. You see, so now we are in here. On the first rotation, remember, on the first rotation. So on the first rotation, we were able to, on the first, yeah, so we were able to get this, and we were able to get this. All right. So now again, on the first rotation, we need to target this. So I is going to be 0, and the J is going to be length minus J, because J right now is 0, right? So length minus 0 is going to give us 3, which is going to be, no, it's going to give, yeah, 3, which is going to be this. So now you see why I had to minus 1 out of length, because normally length is 4, and index starts at 0. It's going to get messy if you don't minus the 1, okay? Oh, I hope I'm not confusing you. Okay, so this is going to be our A3. We're going to do matrix. So I is going to be 0. It's going to be left the same. And then we're going to have full length minus J. Whoopsie. So now we have 119 on the first rotation. So only look at the first numbers when you look at this, okay? So you see we have 119 in our first rotation. Okay, and then finally we're going to be targeting, where did it go? Yeah, we're going to be targeting this here. So I is going to be length minus I, which is 0, and length, and J is going to be length minus J, right? So okay, so now let A4 equals matrix full length, I think, right? Yeah, full length minus I, so I is 0, and then minus J. So this should give us 108. Yeah. Do you see? So now we were able to target all the yellow numbers in the first rotation. All right, so what we can do now is push all of that stuff. So let's do array mirror number. Just put array mirror numbers. Dot push A1, A2, A3, A4, like this. Okay, so now it's going to push all the yellow numbers into array on the first rotation, right? So now on the second rotation, I is going to swap. Well, actually, on the second rotation, J is going to swap to 1, right? So what are you going to get? You're going to get I0, J1. So 42 is going to get pushed into the mirror array, right? So we're talking about second rotation, right? So then I is 0, J is 1, right? And because j is, so again, okay, let's just think about what will the function do, what will the for loop, nested for loops do, right? So when I is 0 and j is, so now j is 1, right? It's going to push this into the array, right? Next thing it's going to do is it's going to look at um, I is still 0, right? So length minus I is still 0, so it's going to be still here. But because j is now 1, it's going to push this into the mirror, right? Array. Because we already finished j0, right? So j0 is gone, right? So it's going to push this. Now, because j is also now 1, we're gonna minus the j out of the length. So it's going to push 83, right? And then because length is still, because I is still 0, we're still sitting in here, right? But because the index of, oh, this is so confusing. So basically, on the second rotation, it's going to push this in, right? That's what it's going to do. On third rotation, now because I has changed and j is 0, it's going to push this, okay? And then finally, right, because um, j is now 1, it's going to push this. That's what's going to happen, right? Now, this is the hardest part. You're gonna have to sit down and draw it, make, I don't know, I had to make gazillion drawings to figure this out, right? But you just have to understand how it works, and then that's it. And then you'll be able to solve it. You see? Basically now, you see, on the second rotation, it will push 42, 90, 98, 83, and 114. So this will be our probably orange numbers. So it pushed this, right? Let me just do it side by side. Okay. Yeah, there you go. And like so. Okay. So you see, we have 42, then 98, then probably, what was the second one? So matrix is I, right? So it's going to be here. So it's probably going to push 83, right? Length minus j. Yeah, so j is now 1 because length is 3. We're minusing. Um, it's going to be 2, which is probably going to be 83. Yes, there's 83. And then full length, which is I0, right? I0, so we're going to be here, right, in this array. And then length minus j, j is 1, length minus 1, we're going to be here. So it's going to push 114. There you go, you see. Then 56, 15, 49, 49, 43, right? 56, 15, 49, 43. And then it's going to, the remainder. So it's going to be 125, 78, 56, 110, right? Yes. Okay. And that's it. So now if we're gonna look into the this thing, you will see that it consists of all of our color matches. So we're gonna console log array mirror numbers. Okay, you see. So we have 12, 62, 119, 108. We have orange 42, 83, 98, 14. Now we have violet 56, 15, 49, 43, and then this thing here. Okay. All right, so now we have done the color coordination thing. Now, remember what I said in the beginning. You just have to find the biggest number out of those colors, and those colors are now in those arrays, right? So the way to do that, we're simply going to do let final one equals array mirror numbers dot map, because we want to pick the biggest number out of every one of those arrays, right? So the way to do that is element. So now if we look at console log element, every element is going to be a separate array, right? So now we just have to use return math max and then dot 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 element. So this will pass every single value in the array into mathmax, and what mathmax is going to look at is going to look at every single value and pick out the highest. So in here it's going to be 119 19, my apologies. I even going to console log this for you. So let a equals this. You see, so it's picking out the biggest number out of every array. So now we have 19, 14, should be 56, should be 125. So there they are, right? So now we looked at this thing here and we picked out the biggest number out of every single one of those colors. And remember, this will take care of itself because one number from every color is going to end up in this quadrant. So if we just pick out the biggest number, they're going to be automatically in there if we just do all the rotations. So we don't even have to do rotations physically. We can kind of do them virtually because they will take care of itself, right? Okay, so now we need to return a. So we are returning every single. So now we're gonna have, if we console log our final, it will consist of an array of the biggest number possible in this quadrant from every color, right? The biggest number possible in every color, and we know that they're gonna be in here because every color will have one number from its color inside of this quadrant, and that's exactly what we're looking for. And then finally, final solution, they want us to give them the sum of those numbers. So let final 2 equals, we're gonna use reduce, right? So final 1, reduce. So we're gonna have accumulator value. Now, normally you need to put 0 in here, but remember how accumulator works, reducer. If you don't specify accumulator, it's going to use the first value as accumulator. So we're going to return accumulator plus value. Well, honestly, I'll just, to avoid even further confusion, I'll just do it very, very simply for you. Remember, when you're doing it with accumulator, always, always, always have to return accumulator, right? That is the fundamental rule of reduce. You always have to return accumulator. And in here, we're going to have accumulator is equal to accumulator plus value. And then once we console log final, we should get 114, and they want us to return final 2. Now, when you are, and that's the solution, by the way. That's it. So if you look at the HackerRank, where is the HackerRank thing? It should be 414. So there it is, 414. Okay, before you're submitting, always remove console logs because console logs lag the system hardcore. And you can fail a test because your code is too slow. And normally the cause of that is console log. Okay, now one console log is fine. So now we're gonna submit the code, see what happens, right? It should pass, honestly. Yeah, there you go. And it's done. Okay, so I hope this was helpful. Just remember, like the core thing is to find the pairs of numbers that can be rotated. I call them mirrors, right? The mirrors. And remember that every single color, one number from every single color will be represented in this quadrant, right? So all you have to do is just pick the biggest number out of the color um, mirrors, or whatever you call them, whatever you want, right? And then the second trick is you have to split into two and use length to be able to access the second part of the array. You cannot use standard for loop, a standard for each, for example, because there will be no way to access these numbers without hard coding. I already tried. And if you're asking, is it going to work on a bigger one? Yes, it will. You can test the code on the bigger. We see input in here. It will still work. I'm not going to show it to you, but what you can do is you can just punch in. Actually, I'll do it for you. Doesn't matter. Might as well do it, okay? So if we do input 3, so now we put in a 6 by 6 matrix, and it's 1795. So now let's look at the biggest number from this thing here. Okay, so yellow, this, so 210. Then green is gonna be 234. Let's just do this, honestly. Okay, so we'll cover green. Now we need to do blue. So it's 242. Okay, let's just look at this. Okay, so it's 52. 152. Red is gonna be 145. 145. And this is gonna be 114, I think, right? I think we covered everything, so it should be 60. So there should be 9 numbers in here, right? I think I missed something. Yeah, I missed this one here. I'm missing another one. Okay, so yellow is done. This is done. Oh my god, this is so confusing. I'm missing one number, I think. Okay, so yellow done. Let's just go this way first. Okay, this is done. This is done. Okay, so this is done, right? Okay, so now we've done this, this, and this. Okay, now we're doing the. Oh yeah, this one is missing. Yeah, there you go. So you see it's 1795, and then here's 17. So this will be a final array of the biggest number from every color. So if we look at in here, that's what we're going to see. Okay. So you see 210, 234, 242, 523, 152, 145. 62 should be, yeah, because I forgot about 62 basically. Yeah, so you see 62, then that's where I got confused. 113 and then 114, and then you just sum them up and you get the answer, and that's it. Because again, remember the fundamental truth of this algorithm is that every one of the color numbers is gonna be in here, and you can get them in there through rotation. So you don't have to rotate the array. You can just target them and pick out the biggest number out of the mirror, and that's it. You just do it, and that's how you solve it. Okay. Take care. Bye bye.